Alright, number 16 is one of the more difficult problems on this review, but it's still pretty doable. So if you're interested in it, here we go. What I'm going to be doing is looking at just the coefficients that we're trying to get, then the x value and the y value that we're going to try to get, and I'm going to do them individually and use this little process of elimination, just reasoning it out. Okay, so we have some number that will go here that's being raised to the negative 4/3 power. So what's that going to do? I'm going to call that number n. It's going to put that number in the denominator and be raised to the 4/3. Well, then it's going to be multiplied by 9 to the 1/2. And it's got to be equal to 3/16. Right, well, let's look at the 9 to the 1/2. What is that really? Well, in radical form, it would be the square root of 9. That right there is the square root of 9, which is 3. Okay, so what we've got is 3 over n to the 4/3 is equal to 3/16. Okay, so now we see that the 9 to the 1/2 gets us the 3, and so all we need is the 16. And the way we get the 16 is that whatever the number is that goes in that blank, raised to the 4/3 power has to equal 16. So n to the 4/3 power must be equal to 16. So I'm going to rewrite n to the 4/3 in radical form. Okay. So that's the cube root of n to the 4th power is equal to 16. Well, how do I get rid of a 4th power? Take a 4th root. Okay. That looks super complicated, but that's just to cancel out the 4th power, which means I have to take the 4th root of the other side. So the cube root of n must be equal to the 4th root of 16 is 2. How do I get rid of the cube root? I cube it. Cube both sides, those will cancel out. You get the n is equal to 8. So the number that goes in that blank is 8. Now, they give you 5 choices, so you could plug things in and just go until you see what works. But there is an algebraic way to figure this out, that we have some knowns and some unknowns, and just like algebra all over the place, you're using mathematical techniques, algebraic techniques, to create equations and then solve those equations. So here you just have to kind of create one on your own. Alright, let's look now at the y values. We'll save the x values for the end because they're the most difficult. Okay. So, what do we have for the y's? We have a y to the negative 9 that's being raised to the negative 4/3. So what do we do to those exponents? We multiply them. Then we're multiplying by, well, now we have a y in the denominator, so there's a y down here, and it's some number times 1/2. So there's some power right here, but it's a power to a power. It's the power 1/2. Okay, so we would multiply those exponents, and it's equal to y to the 10th. So when it's all simplified, everything on the left, it's going to be equal to y to the 10th. So let's combine these. Negative times a negative is a positive, and 9 times 4/3 is 12. So y to the 12th over y to the n times 1/2 is equal to y to the 10th. Well, how are we going to combine those two powers with the same base that are being divided? We're going to subtract the exponents. So when I subtract 12 minus 1/2 of n, I need to get 10. Okay. You can maybe do that intuitively, but that's just a linear equation. So we get negative 1/2 n is equal to negative 2, multiply by negative 2, and you get the n equals 4. So that number right there is a 4. Okay. again, you can just plug in stuff and kind of guess and check, but when you multiply these two at the beginning and you get 12, you know you need a y squared in the denominator so that you can have y to the 12th over y squared, and it'll simplify to y to the 10th. And so what number do you have to multiply by a half to get to? 4. So that's the solution to that one. Whoa. A little overzealous there with my erasing. Let's try that again. Okay, now let's do the most difficult part, which is the x's. We know that we need an x to the 5th in the denominator. So I'm going to call this n and this m, because I have two unknowns this time. And what you should know about one equation is that it's really hard with one equation to get two different unknowns. But we have a number bank, and so there's multiple things we could put in here, but we'll use our bank, and hopefully that'll help us out. So whatever that first x is being raised to is being multiplied by -4/3. Then it's multiplied by x, and that's a half m. So this is being multiplied by this, power to a power. And it needs to equal 1 over x to the 5th. Okay. The 1 is just a placeholder. It's to show that the x to the 5th is in the denominator. Okay, so let's simplify the left side. So we've got x to the 1/2 of some number. Okay, so the -4, nope, not -4/3, +4/3, because I moved it to the denominator of some other number. Okay. So which one of these things needs to be bigger, the half m or the 4/3 n? Hopefully you said the 4/3 n, because I need 5 more x's in the denominator than I have in the numerator. Okay, now this is a whole number. So when I simplify this, the 4/3 n, I should get a whole number. Well, if I do 4/3 times 10, get 40/3, which is equal to 13.3. I don't want that. 4/3 times 8, 32 over 3, which is equal to 10.67. And I don't want that. But look at 4/3 times 6. That's 8. Okay? So I'm going to say that I think this one, the n, should be an 8 as well. Okay. Well, if I'm going to have 8 down here in the denominator, how many do I need to have in the numerator? I need 3. So x to the 3rd over x to the 8th would be 1 over x to the 5th. So can I make that happen? Can I make 1/2 times whatever the power is on x, the m that I put there, needs to be 3, multiply by 2, and you get m equals 6. So that's one possible solution. And I think since they gave us what they gave us, we only have a limited bank to work with. That's what it should look like right there. Oh, why did I? Whoops! I wrote 8 when I should have wrote 6. I'm gonna blame that on it being early in the morning. It's this that I'm focused on, not this. I mean, the 8 is important, but it's what happens when I multiply 4/3 by 6. Okay, so both of those should be 6. -8 plus 3 is -5. Yeah. Okay. Now then you also can do the trial and error method there. Oh, come on. But that 16, it's a really tough one. It takes a lot of trial and error, but it's just a problem-solving type of thing. You have to be able to solve problems using the knowledge that you have, using the skills, using the information that we've given you, or that you've learned. You kind of put them together to solve hard problems. All right, we'll get back to 17 in a new video.